when I hit R, it randomizes all the constants. So, and that includes how the colors are represented. So this one appears to have amplified everything. The constants also include the mutation rate. So you can see here. These are all the constants. And when I hit R, you can see that all the interactions change. And so does the mutation rate. And the mutation rate basically only affects how often matter and antimatter randomly appear. So you can see, and the constants affect how they interact with the electric field and how strong the force of attraction between matter is, either through differences in charges or mass. So there's gravitational attraction, and then there's electric repulsion and attraction. So matter and antimatter attract each other, and like charges repel. So let me hit R again. We'll see how the interactions change and then stabilize into a different pattern if they do stabilize. Because some combinations of constants produce interactions that are less stable and more emergent, whereas some constants produce stable structures. So this one in particular seems to be producing more of an unstable pattern. And you can see that in the form of traveling waves. I don't know why the phone keeps unfocusing. That's really annoying. And there's some kind of like spiral formation. This one probably has a very high mutation chance because of the constant changing. This is interesting. And if I hit R again... So the green represents gravitational fields, whereas red and blue represent electric fields. So red is a positive electric field and blue is a negative electric field. And we also have waves that propagate when charges move. It looks like the effect of gravitational forces are stronger in this one because you can see more green than usual. If I hit R again, we've got some interesting variations in this corner. You can see those waves traveling. And then hit R again. Oh, there we go. Those are some interesting wave patterns. And you can see they're interfering with each other. That must be a very strong concentration of mass right there, because you can see the strong green. Oh, now it's turning blue, which means there's a negative charge concentration forming. Whereas the yellow would be like a positive charge and a high mass, but it looks like the negative charge is sort of replacing it or taking over. some interesting interactions. But yeah, pretty cool little visualizer. It's hexagonal cells, so I made it that way because the square grids were a little too they weren't round, they were more like angular, because the squares, you know, only affect up, down, left, and right, whereas the hexagons more approximate circular structures, so it's a little more round. Hexagons are like the smallest number of sides that easily approximate circles, which is why I chose that. If you put more sides, it would probably be similar, but it would be less of a difference. So it would be diminishing returns in detail. But the hexagons are pretty good at approximating round structures. Every time I hit R, it's a new kind of way that the cells interact with each other. Let's try to get something interesting. Ooh. There we go. We've got some motion. Expansion. Looks like a propagating blue wave, which also bounces off the edges. And the edges are considered just 0 and everything, so anytime there's a cell next to an edge, it counts that area that would have been a cell as 0 mass, 0 charge, 0 any kind of variable. Yep. Cool little visualizer of different interactions.